Alrighty, peeps, here we go. So we're on lesson 1.6. This is the last lesson in chapter 1, which is awesome. So we're going to review Pemdas. So hopefully we remember what Pemdas stands for. P is parentheses. E is exponents. M is multiplication. I'm not going to write that out. D is division. Not going to write that out. A is addition. I'll write add. S is subtraction. I'll write sub. Good enough. So you want to follow, when you have more than one operation in an expression, you want to follow PEMDAS. Otherwise, you're going to get the answer wrong. So I want everyone to try A, B, and C. And see what you can do with A, B, and C. So pause the video, try those questions, then press play, see if you got them right. Okay, so I'm feeling like some people made mistakes. So let's take a look at what I did. So in the first one, letter A, we have parentheses. So we had to do that first. So 5 times 2 is 10. And then we have 10 divided by 10, which is 1. I'm pretty confident we got that one right. B, let's see. Hopefully we got 10. If not, I know exactly what you did. So for letter B, you had to do multiplication first because multiplication comes before addition. So you have to multiply here 3 times negative 2, which is negative 6, and then add the 16 in front. And 16 plus negative 6 is 10. All right, letter C. I also put this one on here because it's very common that people would always choose to write or choose to add before they subtract. But technically, add and subtract is like one. It's like one line, and the multiplication is like one line. So sometimes you'll see PEMDAS written like this, because multiplication and division are kind of interchangeable. You have to do parentheses first. You have to do exponents first. Multiplication, you can switch third and fourth order, and then addition and subtraction is fifth and sixth. So here, letter C, you had to combine left to right. So 20 minus 8 is 12, plus this negative 4, which is positive 8. Okay, so knowing that, let's move on here. So this lesson is about applying integer operations. So there could be more than one operation involved. Could be addition and division. Could be subtraction and multiplication. It could be a mixture of anything. So let's try it. So Hannah made 4 withdrawals of $20. So this is really important. Actually, I should probably follow my directions here first. So first read, you always want to read word problems 3 times, because studies say that it actually takes 3 times to comprehend what the question's asking and to really get a good grasp of what you're dealing with. So first read. So we'll read it. It says, Hannah made 4 withdrawals of $20 from her checking account. She also wrote a check for $215. By how much did the amount in her checking account change? Okay. Second read, underline the important facts. So let me highlight. I think I have a highlighter. So Hannah made 4 withdrawals of $20. Very important that you not only highlight 4, but also withdrawals and 20 from her checking account. She also wrote a check for $215. By how much did the amount in her checking account change? Okay. So write an expression to represent the first operation. The first operation is what I first highlighted. So 4 withdrawals of $20. So you should know at this point that a withdrawal is taking money out. So you have to have $20 as a negative. So she did this 4 times. So we're going to multiply that by 4. Okay, so continue the expression to represent the second operation. So that's the second thing that I highlighted here. So she also wrote a check for $215. When you're writing a check, you lose money. It's going somewhere else, not yours anymore. So we have to make that negative. And then evaluate the expression. It says, how much did the amount in her checking account change? So we're just going to add those 2 situations together. So 4 times negative 20 plus negative 215. And then we solve. So 4 times negative 20 is negative 80 plus negative 215, which ends up being negative $295. So that is the change in her account. You could also write her account, abbreviating, decreased by $295. But what I have circled here is completely appropriate. All right, letter B. Oh my gosh, I'm like drawing all over here. Okay, let's pick a different color. I'll do blue. So first read, understand the situation. So Reggie lost 3 spaceships in a level of a video game. He lost 30 bonus points for each spaceship. When he completed the same level, he earned a bonus of 200 points. By how much did his score change? So kind of the same thing, but like we're talking about a game as opposed to her checking account. So I'm going to read again and underline or highlight important facts. So Reggie lost 3 spaceships. So lost 3 spaceships. Then he lost 30 bonus points for each spaceship. When he completed the same level, he earned a bonus of 200 points. By how much did his score change? Okay, so here we're going to follow the same steps as we have up here. So write an expression for the first operation. So the first thing I underline. He lost 3 spaceships. And then he lost 30 bonus points for each spaceship. So that would be a negative 30. And then times 3. I was pausing a little bit because I could see people putting negative 3 and negative 30. But if you do negative 3 and negative 30, you end up with a positive. So we only have to kind of account for this lost word once. And I would say in the points. Because if he lost 3 spaceships, they each were worth 30 bonus points. So he lost these 30 bonus points times 3. Okay. And then he earned a bonus of 200. So plus 200. And then you solve. So 3 times negative 30 is negative 90. Plus 200, you should get 110 points. Cool. All right, comparing integer values. So this, when we have comparing, seems like you have to do 2 separate expressions and then kind of answer the question they're asking. So first we have here is less than. Hopefully you remember that. And then this one is greater than. And I think I want a new color. Green. But I need a highlighter. Okay. So comparing integer values. Jill and Tony play a board game in which they move counters along a board. Jill moves her counter back 3 spaces 4 times and then moves her counter forward 6 spaces. Tony, okay, so that was Jill. Let's get some other color for Tony. Yellow's good. Tony moves his counter back 2 spaces 3 times and then moves his player forward 6 spaces 1 time. So find each player's overall change in position. Who moved farther? So what I would like you to do right now is pause the video and write an expression for Jill and then write an expression for Tony. I'm going to show you what those expressions are, but why not take a moment and write the expressions out to see if you can do it without me first. So press pause now, see what you can do. Okay, so I wanted to wait to write them so you can understand where I'm getting them from. So Jill moves her counter back 3 spaces 4 times. So back 3 spaces would be negative 3. That happens 4 times. And then she moves her counter forward 6 spaces, so that's plus 6. Tony moves his counter back 2 spaces 3 times, so back 2 spaces 3 times, and then moves his player forward 3 spaces 1 time. So find each player's overall change in position. You just have to solve. Here he has negative 3, and this is negative 12 plus 6, which is negative 6. So who moved farther? Oh, I actually remember this question. Who moved farther is a kind of a challenging question because it's kind of confusing to think about. So basically, every player starts at 0. So we start at 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and then 1, 2, 3, 4, 5, 6. So what's happening is they're moving, this way and then this way. They're going forward and then back. So where we end up, Jill ends up here, Tony ends up here. Who moved farther is who's farther from 0, which is Jill. And that's kind of confusing to think about. Typically, the question would be not who moved farther, but whose change was greater. I guess the answer is still Jill, regardless. But it's just kind of, you have to really think about the game itself and to decide who moved farther. All right, so here we have Amber and Will. I would like you to pause right here. You're going to come up with an expression for Amber. You're going to come up with an expression for Will. And then you're going to decide who moved farther back in line. So again, press pause. And when you're ready to see if you got your answer right, then press play. Okay, here's my expressions. So Amber moves back by 3 places 3 times. So that's where the -3 comes from there, 3 times. And then she's invited to move up 5 places. Will moved back by 4 places twice. And then up by 3 places. -9 plus 4 is plus 5 is -4, and -8 plus 3 is -5. So who moved farther back in line? That would be Mr. Will here. Alrighty, cool. So you have some questions I want you to do on your own, so you can stop the video. And then when you are finished with all of these, or if you have any questions at all on how to solve these, just raise your hand. Again, when you're finished with this, let me know. And then I'm going to check these answers, and I'll have you move on to something else. All right, good luck.